based in Seattle, and have spent the last couple of days decades building software. Hiring software engineers and mentoring people through different stages of their careers. And in this video, I want to talk about 5 projects that will actually help you get hired in 2026. And no, I'm not talking about yet another project with a big name but no substance just to add to your resume, but actually useful projects that's and how real software engineering teams work. These are ideas I've either been working on myself or consistently recommending to people that I mentor because of how well they map to the real world, whether it's their application or in the software engineering skills companies are looking for right now. All right, let's get started. First up is Bug Fixer. Every engineering team has a bug backlog. And in most teams, the long tail of small bugs or low priority bugs just never gets touched. Bug Fixer is an AI-driven tool that plugs into any repository, reads bug reports and attempts to reproduce them, proposes fixes, and even opens pull requests. The value of this project isn't the AI novelty, it's what it says about you. You're demonstrating that you understand developer workflows, CI pipelines, testing discipline, and how engineering velocity is actually improved in practice. This matters especially if you're just graduating or a junior software engineer. Start simple, a Python script, GitHub APIs, and an LLM API for patch generation, and maybe something like PyTest for validation. Then you can scale up. Docker for sandboxing, Phase for smarter code retrieval, and maybe LangChain if you want multi-step logic across agents or patches. By working on this project, you'll learn how to interpret natural language bug reports and connect them to real code. You'll also practice generating and testing AI-suggested patches, understand how to integrate with developer tools like GitHub and various test frameworks.
LangChain and LangGraph are both open source frameworks designed to help developers build applications with large language models. So what are the differences and why use one over the other? Well, I think a good place to start is to define what these two things are. And let's begin. With LangChain. Now we've done a dedicated video on LangChain, and my guess is there's probably a pop-up somewhere over my head right now encouraging you to watch that video. But don't click, not yet. Give me a moment to summarize LangChain. Then at the end of this video, if you want to know more, you can go back and check that one out. Okay, now at its core, LangChain is a way for building LLM-powered applications by executing a sequence of functions in a chain. So let's say we're building an application, and the first thing it needs to do is it needs to retrieve some data from a website. Once we've done that, we move on to stage 2, and stage 2 is to summarize that data that we retrieved. And then finally, we're going to use this summary to do something. Specifically, we're going to have it answer user questions. So the workflow here is retrieve, summarize, and answer. And we can use the LangChain to help us do this. So let's start with the retrieve component. Now the retrieve component might consist of a LangChain component called a document loader. Now a document loader is used to fetch and load content from various data sources. And if some of those documents are large, we might choose to use a text splitter, which is another LangChain component, to split text up into smaller, semantically meaningful chunks. Okay, that's retrieve. Now, to summarize, we would use a chain. And the chain will orchestrate the summarization process. Now that might include constructing a prompt component to instruct an LLM to perform a summarization, and it might also contain an LLM component to pass that request to the large language model of our choosing. Okay, and for answer, well, we would build another chain, and this chain might include a memory component. So this is another component of LangChain, and that's used to store conversation history in context. And we throw in another prompt component and another LLM component to generate the answer based on the summary and record context. And the cool thing here is that the LLM that we use for the answer component may be a completely different large language model to the one we use in the summarize component. LangChain's modular architecture lets us build complex workflows by combining these high-level components. Okay, now let's introduce LangGraph. LangGraph is a specialized library within the LangChain ecosystem, specifically designed for building stateful multi-agent systems that can handle complex non-linear workflows. So let's consider a task management assistant agent. Now the workflow here involves processing user input. So let's start there, process input. And then to this workflow, we are going to allow to add tasks. We're going to be able to complete tasks. And we are also going to be able to summarize tasks. So this is the kind of the architecture of what we're trying to build here. Now LangGraph helps us create this as a graph structure, but each one of the actions is considered as a node. So add tasks, complete tasks, summarize, they're all nodes. And then the transitions between these things, that's known as edges. Now the central node is the process input node, so that's where the user input comes in. And that's going to use an LLM component to understand user intent and to route to the appropriate action node. Now there's another component here, it's quite central to this, called state, the state component. And the state component is used to maintain the task list across all the interactions. So the add task node adds new tasks to the state, the complete task node marks tasks as finished, and then the summarize node uses an LLM to generate an overview of current tasks. All nodes can access and modify the state, allowing for contextual, stateful interactions. The graph structure allows the system to handle various user requests in any order, always returning back to the process input node after the action is complete. LangGraph's architecture lets us create flexible, stateful agents that can maintain context over extended interactions. So let's already compare LangChain and LangGraph across a number of dimensions. Let's start with the primary focus. Now the primary focus of LangGraph is to create and manage what is known as multi-agent systems and workflows. The focus of LangChain is to provide an abstraction layer for chaining LLM operations into large language model applications. That's the difference between the two. Now, as for structure, LangChain adopts, and no surprise here, a chain structure, and that acts as a DAG. DAG is an acronym for Directed Acyclic Graph, which means that tasks are executed in a specific order, always moving forward. So, for example, we start with task number 1, then we have a branch for maybe task number 2 and task 3, and then we come back to the central task number 4. And this process is great when you know the exact sequence of steps that are needed. Now, LangGraph's graph structure, on the other hand, is a little bit different because it allows for loops and revisiting previous states. So we might have state A, which can go backwards and forwards with state B and state C. And this is beneficial for interactive systems where the next step might depend on evolving conditions or user input. Now, when it comes to components, LangChain uses a bunch, and we've mentioned many of these already. That includes memory, there's the prompt component as well, there's also the LLM component, which is how we actually pass things to the large language model, and there's the by allowing for more complex context-aware. For large language models to be truly useful, they often need to interact with external data sources and services and tools, and until recently, that was typically done with application programming interfaces or APIs. Now, in late 2024, Anthropic introduced a new open standard protocol. That's Model Context Protocol, or MCP, and it has already made quite the splash, and it standardizes how applications provide context to LLMs. So let's define these two terms, MCP and API, and take a look at their similarities and differences. Now, a good metaphor for MCP is that it's kind of like a USB-C port for your AI applications, and that's because it standardizes connections between AI applications, LLMs, and external data sources. So if you think about just your standard laptop that you might be using, well, that probably has a set of USB-C ports attached to it. It's a really old one. And in those ports, well, you can plug in all sorts of cables, and they all use the USB-C standard to interface with all sorts of peripherals.
It seems like every developer in the world is getting down with MCP right now. Model Context Protocol is the hot new way to build APIs. And if you don't know what that is, you're NGMI. People are doing crazy things with it, like APIs. And if you don't know what that is, you're NGMI. People are doing crazy things with it, like this guy got Claude to design 3D art in Blender powered entirely on Vibes. And just a few days ago, it became an official standard in the OpenAI Agents SDK. If you're an OG subscriber to this channel, you probably know what a REST API is. You might even know about GraphQL or RPC, or maybe many years ago you used SOAP. When I was a kid, the software engineering gatekeepers told me I couldn't be a web developer unless I could explain the difference between these architectures and protocols. Well, now the turns have tabled, and these gatekeepers have been utterly demolished because we're all just vibe coders now, embracing the exponentials, pretending code doesn't even exist, and just chilling with LLMs until we get the end result we're looking for. That being said, you can't call yourself a true vibe coder unless you know about Model Context Protocol, which is basically a new standard for building APIs that you can think of like a USB-C port for AI applications. It was designed by Anthropic, the team behind Claude, and provides a standard way to give large language models context. And they're so bullish on this technology that the CEO of Anthropic said he expects virtually all code to be written by AI by the end of the year. In today's video, we'll actually build an MCP server and find out if it can truly make the world a better place by eliminating all white-collar jobs. It is March 31st, 2025, and you're watching The Code Report. Contrary to popular belief, Fireship is still a tutorial channel. In today's video, we'll take a storage bucket, a Postgres database, and a regular REST API, and then connect them all together with the Model Context Protocol. Not only will this allow Claude to have access to data it didn't have before, but it can also execute code on our server, like write to the database or upload files. And people of the internet are already using it to do crazy stuff, like automated stonk and shitcoin trading, industrial scale web scraping, and as a tool to manage cloud infrastructure, like your Kubernetes shitcoin trading, industrial scale web scraping, and as a tool to manage stuff, like automated stonk and shitcoin trading, industrial scale web scraping, and as a tool to manage cloud infrastructure like your Kubernetes cluster. Speaking of which, to build our own MCP server, we'll need some cloud infrastructure, and one of the best places to do that is Savala, which itself is powered by Google Kubernetes Engine and Cloudflare under the hood. They were nice enough to sponsor this video, but the reason I like their platform so much is that it's far easier to use. Now, like other API architectures, MCP has a client and a server. The client, in our case, will be Claude Desktop. Then we'll develop a server that maintains a connection with that client, so the client and server can pass information back and forth via the transport layer. Now, in a REST API, you have a bunch of different HTTP verbs that you can send requests to via different URLs, but in the Model Context Protocol, we're really only concerned with two main things: resources and tools. A resource might be a file, a database query, or some other information the model can use for context. Conceptually, you can think of it like a GET request in REST. Meanwhile, a tool is an action that can be performed, like writing something to a database, so that'd be more like a post request in REST. What we do as developers is define tools and resources on the server so the LLM can automatically identify and use them when they have a prompt that needs them. In my life, I've been working on an app I consider my magnum opus called Horse Tinder, but as it turns out, swiping left and right was a bad feature idea because horses don't have fingers. So like every other failing startup in Silicon Valley right now, we're going to pivot to artificial intelligence. Luckily, we can leverage our existing data and servers. Like here in Savala, I have a storage bucket, and it contains all the photos that my users uploaded. In addition, for user data, we have a Postgres database. It has all the profile data for each one of our horses, as well as the relationships they form together. And then finally, I have a traditional REST API written in TypeScript that fetches this data for my web, iOS, and Android apps. And what's especially cool about my code is that it's in a Git repo hooked up to a CI/CD pipeline. That means after we write our Model Context Protocol server, we can push our code to the dev or staging branches to test it before it actually goes into production, while Savala automatically handles all the deployments and cache busting for us automatically. And now we're ready to jump into some code. Here I have a Deno project, and the first thing you'll notice is that I'm importing a class called MCP Server. This comes from the official SDK, but if you're not using TypeScript, they have a bunch of other languages like Python, Java, and so on. We'll also be using Zod here, which is a tool used for schema validation, which allows us to provide a specific data shape to the LLM, so it doesn't just hallucinate a bunch of random crap. Now, after we create a server, we can start adding resources to it. The resource will first have a name, like horses looking for love, and then the second argument is a URI for the resource. Then finally, the third argument is a callback function that we can use to fetch the data. In this example, I'm writing a query to our Postgres database, which is hosted in the cloud on Savala, then accessed on the server with the Postgres.js library. But you could access any data here. When something is a resource, though, it should only be used for fetching data where there's no side effects or computations. If you do have a side effect or computation, you should instead use a tool. Like for Horse Tinder, we might want the
So, you're thinking of becoming an AI engineer. That's cute. You've seen the job titles on LinkedIn, you've watched some YouTubers say AI is the future, and now you're wondering if it's your turn to join the algorithmic elite. You're imagining yourself building the next Jarvis, or at least a chatbot that doesn't call people lizards. But let's talk about what being an AI engineer actually looks like. Because spoiler, it's not all robots and glory. It's mostly Python scripts, cleaning spreadsheets, and waiting 3 hours for your model to converge, only for it to still predict that a dog is a cucumber. But before we start, please like this video and subscribe to become a fellow codehead. Alright, back to the video. So what even is an AI engineer? Think of it as a weird hybrid between a data scientist, a back-end engineer, and someone slowly losing their grip on reality while trying to optimize a loss function. Engineer, and someone slowly losing their grip on reality. Hybrid between a data scientist, a back-end engineer, and someone slowly losing their grip on reality while trying to optimize a loss function. In simple terms, you're designing and implementing systems that use machine learning or deep learning to do stuff like recognize speech, generate text, detect fraud, or recommend YouTube videos you didn't ask for. You're building the brains of modern software, which sounds cool until you realize those brains are mostly trained on Reddit, comments, and mislabeled cat photos. Day to day, you're deep in code. Python is your lifeblood. You'll be using libraries like PyTorch or TensorFlow, wrangling APIs and orchestrating containers just to deploy a model that still performs worse than a logistic regression from 2009. And yes, you're also doing infrastructure work, writing Docker files, tuning GPU instances on cloud platforms, and wondering why your bill just went up by $200 overnight.
Well, no, this can't be.
Now let's talk skills. First off, math. Not just I can do my taxes math, actual serious math. Linear algebra, calculus, statistics. You need to understand how gradient descent works, why activation functions matter, and what in God's name an eigenvector is. If that sounds intimidating, good, it should be. This field is a beautiful mess of theory and practice, and you can't rely on just copying Stack Overflow answers for everything though. Let's be real, you'll still try. Then there's programming. If you don't know Python, you're not getting very far. You need to be comfortable writing scripts, using Jupyter notebooks, handling large datasets, and debugging models that keep predicting the same output no matter what you feed them. SQL is also handy because guess what? Your magical AI model is useless if you can't pull the data out of the database in the first place. And speaking of data, get used to it. 80% of your time will be spent cleaning, normalizing, and labeling it. You'll look at CSVS until your eyes bleed. You'll realize that most real-world data is just broken, inconsistent nonsense, and that data quality is the real boss battle of AI engineering. So what's the work like? Well, a typical day might start with a new dataset. You explore it, clean it, try to find meaningful features, and then set up your model. Maybe it's a neural net, maybe it's a random forest, maybe you just slap on XGBoost because that's what everyone else does. You train the model, stare at the loss curve, tweak a few hyperparameters, and wait, and wait, and wait. Finally, it finishes training and gives you results slightly better than flipping a coin. Congratulations. You're now an AI engineer. But is it worth it in terms of money? Yeah. AI engineers are among the best paid roles in tech right now. If you know what you're doing, you can pull 6 figures easily, especially if you're working on large language models or applied AI or ChatGPT. If your model's accuracy by 0.2%, this path will destroy you. If you want clear answers and fast feedback loops, go build front ends. AI is a jungle of uncertainty, constant experimentation, and models that work perfectly in training and then collapse the moment they touch the real world. That said, if you love puzzles, don't mind getting your hands dirty with messy data, and enjoy the thrill of solving problems in weird, probabilistic ways, this might be your dream job. Just don't go into it expecting to build superintelligence on day one. You're more likely to spend 2 weeks trying to figure out why your GPU isn't being used because you forgot to call to device. So should you become an AI engineer? Maybe, but don't do it just because it's trendy. Do it because you're curious, because you love learning, and because you're okay with being humbled by a model that thinks every image is a banana. And if you do choose to step into the AI world, there's one thing you'll learn fast. Good data beats fancy models every time. And that brings us to this video's sponsor, Decodo, a platform
AI to automatically create matches and set up dates between horses. We already have a RESTful API endpoint that can handle that, and we could actually leverage that code here, essentially creating an API for our API. In fact, many of these MCP servers are actually just APIs for APIs, and that sounds like dumb over-engineering, but having a protocol like this makes it a lot easier to plug and play between different models, and just makes LLM apps more reliable in general. Case in point, notice how I'm using Zod here to validate the shape of the data going into this function. That prevents the LLM from hallucinating random stuff here. Basically, when you prompt Claude, it's going to need to figure out the proper arguments to this function, so providing data types along with a description will make your MCP server far more reliable. And then the final step is to run the server. In this case, I'm going to use standard IO as the transport layer to use it locally, but deploying to the cloud, you can also use server-side events or HTTP. Congratulations, you just built an MCP server. But now the question is how we actually use it. To use it, you'll now need a client that supports the model context protocol like Claude Desktop. There are many other MCP clients out there if you don't want to use Claude Desktop, like Cursor and Windsurf, for example, and you can even develop your own client, but that's an entirely separate topic altogether. Once installed, you can go to the developer settings, which will bring you to a config file where you can add multiple MCP servers. In the config file, all you have to do is provide a command to run the actual server, which in our case would be the Deno command for the main.ts file where we defined our server code. You'll need to restart Claude, but then it should show your MCP server is running. In this case, my horse is running, which means I should probably go and catch it. Then you can go back to the prompt screen to attach it. That's going to fetch the resource from the server, so Claude can use it as context in the next prompt. And because Claude is multimodal, you can also add PDFs, images, or anything else to the context really, like all the horse images in our Savala storage bucket. And now magically, you can prompt Claude about things specific to your application. Like if we want to find out which horses are single and ready to mingle, we can make a prompt like this, and it will use the context that we just fetched from our database. Then if we want Claude to write to the database, we can make a prompt like this, where it'll connect 2 horses from the context on a date. You'll need to grant permission to do this, and then Claude will automatically figure out which data to send it, but based on the schema we validated with Zod. And it'll use our server tool to mutate data in the actual application. I can't imagine anything ever possibly going wrong here, and Anthropic is extremely bullish on this being the future. Like their CEO just said that 90% of coding will be done entirely by AI within the next 6 months, and nearly all code will be AI generated within a year. I'm gonna go ahead and press X to doubt there, and I think it's only a matter of time before some AI agent accidentally wipes out billions of dollars in customer data, or becomes self-aware and just deletes the data for fun. That being said though, there's all kinds of amazing tools being built with MCP right now, and you can check those out on the awesome MCP repo. Just please make sure to vibe code responsibly. Huge thanks to Savala for making this video possible, and enjoy this $50 stimulus check to try out their awesome platform. This has been the Code Report, thanks for watching, and I will see you in the next one. It seems like every developer in the world is getting down.
Hey everyone! Today I want to talk about becoming an AI engineer, but with a realistic approach that acknowledges where most people actually start. There are tons of AI engineer roadmap videos claiming you can become an AI engineer in just a few months. As someone who does applied machine learning at Amazon with a focus on machine learning infrastructure and content understanding with Gen AI, I can tell you, for real, becoming an AI engineer at a major tech company takes significant time and dedication. But the good news is, you don't need all those advanced skills to start building useful AI applications. Most self-taught developers don't begin at big tech companies. They start with personal projects, work with startups, or build their own AI apps, learning as they go. So let's break down a more realistic roadmap that shows what you actually need at each stage of your journey. First, let's clarify what an AI engineer actually does, because many roadmap videos don't even describe the right role. They're often describing data science or traditional machine learning engineering. An AI engineer is not primarily someone who trains models from scratch like a data scientist or machine learning engineer would. Instead, AI engineers build applications on top of pre-trained foundation models like GPT-4 or Llama, focus on model adaptation through prompt engineering, RAG, and fine-tuning, prioritize scalability, evaluation,
and have spent
Say I have this roadmap with all the houses, the
and have
colors,
spent
the
the
dogs,
last couple
but
of
I'm only
decades
interested in
building
the road
software,
and
hiring
these 5
software engineers,
houses.
and
There is a
mentoring
way to
people
simplify
through
the map
different stages
by
of their
transforming the
careers.
only two
And in this
things I
video,
need,
I want to
the
talk
houses
about
and the
5
roads
projects
into
that will
points and
actually
lines.
help you get hired
These points
in
are formally
2026.
called
And no,
vertices,
I'm not
and the
talking
lines
about yet
edges.
another project with a
The
big name,
diagram
but
that results
no
is
substance
called a
just to add
graph,
to your resume.
which will give the
But
name
actually
G.
useful projects that
for
signal
graph.
to the hiring team
Well,
how you
okay,
think,
what
how you
can we do with this
operate,
shape? The
and
first
whether
thing
you
to
understand how
understand is
real
not
software
only what is
engineering teams
happening
work. The
visually,
ideas
but
I've either
algebraically.
been working
The
on
label of each
myself
vertex
or
is
consistently
straightforward.
recommending
It's
to
V1,
people that I
V2,
mentor
V3,
because
etc.
of how
But the
well
edge
they
is the
map
connection
to
between
the
the
real
two,
world,
labeled
whether
as
it's
V1,
their
V2,
application or
V2,
in the
V3,
software engineering
etc.
skills
We don't have
companies
any
are
other
looking for
conditions
right
like
now.
directions,
All right,
so it
let's
doesn't
get
really
started.
matter if
First
we
up
say
is
V1,
bug
V2
fixing.
or
Every
V2,
engineering
V1.
team has a
The pairs
bug
are
backlog.
unordered.
And in
This
most
entire
teams,
construction
the
is known
long
as a
tail
simple
of
graph.
small
There are
bugs
other
or
types of
low-priority
graphs,
bugs just never
multi-edge
gets touched.
graphs,
Bug
which have
Fixer
several
is an
edges
AI
in the same
tuning tool that
vertices,
plugs
and
into
they're
any
loose.
repository,
We won't
reads
delve
bug
into
reports,
these,
and
but I will
attempts to
discuss other
reproduce them,
possibilities.
proposes
You know how we
fixes,
started
and
with the
even
street
opens
and its
pull
roads?
requests.
Well,
The value
sometimes
of
these
this
have
project
directions,
isn't
like
the AI
single-way
novelty,
streets. There are
it's
graphs
what it
for that,
says
called
about you.
digraphs.
You're
Much
demonstrating
of these
that you
revolve
understand
around
developer
talking about
workflows,
ways of
CI
getting from one
pipelines,
vertex
testing
to
discipline,
another,
and how engineering
which is known
velocity
as
is
walks.
actually improved in practice.
In our graph,
This matters
V1,
especially
V2,
if you're
V5
just
is a
graduating
walk of
or a
length
junior
2,
software engineer.
for example.
Start simple, a
This
Python
walk is
script,
also a path,
GitHub
because
APIs,
no
and
vertex
LLM
appeared
API
more
for
than
batch
once.
generation, and maybe something like PyTest for validation. Then you can scale up.